Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. In this tutorial, we'll explore the numpy.arccos function, which is part of the numpy library in Python. This function computes the inverse cosine, arc cosine, of each element in an array. The output will be in radians. #### What is numpy.arccos? The numpy.arccos function calculates the inverse cosine of a number, which is the angle whose cosine is the specified number. The input values must be in the range of -1 to 1, as these are the valid outputs for the cosine function. The result will be in radians, where arccos, 1, returns 0. Arccos, 0, returns pi/2, approximately 1.5708. Arccos, -1, returns pi, approximately 3.1416. ### syntax. X, array-like, the input values for which to compute the cosine. The values must be in the range -1, 1. ### returns. An array of the same shape as X, containing the inverse cosine of each element in radians. ### example usage. Let's go through a step-by-step example. ### Step 1, import numpy. First, we need to import the numpy library. If you don't have it installed, you can install it using pip. Now, let's import it in our Python script. ### Step 2, define input values. We'll create an array of values for which we want to compute the cosine. Remember, the values must be between -1 and 1. Step 3, compute the cosine. Now, we can use the numpy.arccos function to compute the cosine for our array of input values. Step 4, display the results. Finally, we can print the results to see the computed values in radians. ### complete example code. Here's the complete code snippet for the above steps. ### output. When you run the above code, the output will be ### conclusion. The numpy.arccos function is a powerful tool for performing inverse cosine calculations on arrays. Remember that the input should strictly be in the range of -1 to 1. The output is given in radians, which is commonly used in scientific computing. If you need the result in degrees, you can convert radians to degrees using numpy.degrees. Feel free to explore more with different input values and use numpy functions to perform additional mathematical operations.